want to now move on to some specific examples of adaptation in two different areas. The first of those is around housing. So there are a number of different ways that houses could be enhanced to have greater climate resilience. The first is around the house structure itself. We would want it to be resilient to damaging climate events. We just need to look at some of the satellite images that we saw of damage in the Caribbean to the recent hurricanes in 2017 to show how not having structures that are resilient to strong winds can lead to incredible damage. That's the same in many African contexts, particularly in the coastal area. So we want resilience to strong winds, to heavy rain, to localized flooding, and even to fire, which is a really critical problem, particularly in informal settlements, where a fire in one dwelling can then rapidly spread to across a whole informal settlement, and particularly if climatic conditions are conducive to that fire spreading, for instance, strong winds and warm temperatures. So some examples of building in wind resilience include work that's been done actually in Southeast Asia, in Vietnam, where they had a competition to actually get people on the ground to propose ways that local houses could be designed in a way that increases resilience to hurricanes, or as they're known in Southeast Asia, typhoons. And one of the critical ways was a roof design that deflects rather than concentrates wind. So that having a roof at a particular angle to the prevailing wind condition actually then results in the wind flowing around the roof rather than acting as a stress on the roof. The second way that you can build wind resilience is through actually anchoring the roofs. Many roofs are actually not designed in a way to actually be locked down and prevent them lifting off in a strong wind. They're just sort of nailed in place on the tops of walls, and the nails go down vertically. So if you have lifting, then the nails don't serve any purpose to lock it in place. So you can actually design the way that roofs, and particularly the struts of the roof, are locked onto the underlying structure of the house to make them much more resilient to these winds. And then the final way is actually the shape of the building itself. So square buildings and particular angles in the building in the prevailing winds can act to concentrate stress from wind, whereas if you have rounded walls and shapes that allow the air to flow around more easily around the actual structure of the house itself, you can reduce stresses on the building. A second way of building resilience is to flooding. So a lot of urban areas are in flood-prone areas. So you want to basically be able to live with the floods that are inevitably going to affect your house. So one of those is actually raised houses. So you build houses on stilts, for instance, or find a way that up to a certain level the water flows beneath the house. And then also really important is the internal design of the house. So in cases where the flooding actually does penetrate the house, you want critical features to be higher up in the house. So you don't want your wall plugs 6 inches or 6 centimeters above the floor. You want them higher up. You want the electric wiring to be at the top of the rooms rather than under the floors, for instance. And you want critical electronic equipment to be located above the ground. So, for instance, if you're thinking of stoves, ovens, TVs, fridges, make sure that they are raised rather than on the ground. And then a really important aspect of that in a flooding context is to have good escape routes. So often if a house is flooded, it's difficult to get out of the ground floor. So you need escape routes onto the roof so that then rescue and evacuation can actually happen. You don't want people to be trapped in a house with water rising around them, for instance. The second way that we can develop climate resilient housing is by minimizing some of the sort of less extreme impacts of other climate stresses. So one of those is heat stress. One can design a house in a way that during those hot periods, it doesn't warm up as much through good insulation and through also just the way the house is aligned in that particular geographical area. So do you want a north-facing house that then is in shade a lot of the time. Those kind of issues, those kind of factors can really reduce the sensitivity to heat stress. And then also water sensitivity. In the week, we've talked a bit about water-sensitive urban design already, but there are ways that you can make a house less of a stress on the water supply system, for instance, through using rainwater harvesting and grey water systems, so that when the larger city system is under stress, this particular house is able to, I guess, survive the stress more easily. The third way that we need to think about climate resilient housing is building resilience to wider disruptions in the city. So this is for using mechanisms such as food storage. You want a house to be able to store food for maybe 3, 4, 5 days in case there's a larger climate disaster within the city that prevents access to food or prevents food coming into the city. So having storage facilities that enable that to happen would build local resilience in the house to wider stresses. The same with regards to water storage, and perhaps also sanitation systems that aren't dependent on immediate and direct coupling to the municipal sanitation system, but you can have local storage that is then of sewage that is then released into the municipal system if and when the opportunity arises. Then also resilience to loss of electricity. So sources of local power, lights that have built-in batteries so that when there are power cuts, perhaps due to a wind impact on electricity infrastructure, you can continue to have at least a minimal amount of electricity supply in your house. And then the final area of resilience building is around the layout of the actual neighborhood within which houses are built. So we can think of layouts that really improve the access, for instance, for emergency services. So if there is a climate or other related disaster, help can come and get there very quickly. You can lay out the structure of the community to reduce fire risk, which I've talked a bit about before, and also the layout to ensure that there are good escape routes should you have to evacuate from your house, and that there are shelters that the community can use that are accessible and safe when climatic risks or disasters actually hit them. So that whole design process to make it easy to move to a place of shelter is also really important.